Hi, this is Passionate Pat with EnergySaverGuy.com. What we're doing today is showing how you can save some energy by insulating the hot water distribution pipes in your home. The tools you're going to need is some pipe insulation. It comes in a couple different versions. This happens to be for 3/4 inch copper, which this is 3/4 inch copper. These other smaller ones, which a little bit smaller hole, is for 1/2 inch copper, which there'll be some up here. So the tools you're going to need is the pipe insulation, some silver tape, a sheetrock knife, tape measure. Okay, what we're trying to do here is, in a winter climate, this is a cement block foundation, and as of right now, it's not insulated. So let's say when it's 0 out, there's not very much R value or barely none to a cement block wall. And what's happening is we have the hot water pipes in very close proximity to this wall. So what we're trying to do here by insulating these pipes is have the hot water stay hot while it gets to its destination. Okay, the first thing we're going to do here is take a tape measure and get an idea of a length. But before we do that, I'd like to explain one thing. Let's make believe this is a 90-degree angle with some pipe. Okay, what we're doing is it would just be the typical thing of just like what that is, 90 degrees. What we're going to do, in order to split that 90 degrees, here's a framing square. That's 90. And then this would be 45. So what we're going to do is cut this pipe insulation at a 45-degree angle. So what we're going to do is, let's say starting right here, we're going to get this measurement, add a little bit, let's call it 11 inches. So what we would do is take the 3/4 inch pipe insulation and measure something like 11 inches. You don't have to be 100% accurate. And then we'd cut it on a 45. Okay, so that's a start. Then what we'll do is just slide this piece right on here. Okay, you can tell by that I'm a little bit long. What we're going to do is maybe just modify it a little bit and take a 1/2 inch off. Okay, there we go. That's a start. Now what we're going to do is take this next measurement, and obviously we know there's going to be a 45 here on the bottom and a 45 here on the top. We'll get a rough measurement here for openers of something like, we could call it, let's say 12¼ inches. So we still have this piece of pipe here with the 45 on it, and we know it's 12¼ from one angle to the other angle. So we'll do something like this. Okay, looks like we got lucky on that one. That's perfect. Now in this area here, being that this is a combustible area, and here's the smoke, carbon monoxide, spent gas is going up the chimney, we're going to stay a good, say, maybe 10 inches, a foot away from this area. Okay, so what we would do there is, let's call it 15 inches from the miter, which is the 45-degree cut, to the straight cut. So we'll go back to the cutting table. 15 inches. Okay, there's our first start. Now that we have a rough fit, what we're going to do, we have 3 pieces up. We know we're roughly in pretty good shape in terms of the lengths. We're just going to pop these back off and take the adhesive covering off. What we did here too is, why we're staying away from this area is because basically it's a fire hazard if this was very close to where the affluent's coming out of the hot water heater. And there we go. Now what we're going to do, just to get a little bit more of a connection, we're going to take some silver tape. This is fireproof tape. What we're going to do is just maybe take, say, 6 inches of it. Once again, take the adhesive covering off. Squeeze the insulation together. And this is going to ensure that we have a leak-proof connection. So just keep going with this process, cutting the 45s. There's also a nice way what you can do. What I'll do is one more. Let's just point out here how this pipe meets up there in a T to 3/4. Okay? What we're going to do is we know we have a joist in a way, so even without measuring, we'll say that that's 2.5 inches. And I'll show you a little way to do this. Okay, we're going to call it even 2 inches. We're going to go to that joist, which we know it's going to be, say, typically between these joists is usually in the 14.5 area. So we'll cut a piece of the 3/4 inch pipe around 14.5. Then what we're going to do is hold it up, and we know that we have this pipe meeting it. So we're going to just take out a little bit of insulation in that area. Now this is a nice little Saturday morning project where you could just put an hour in here, an hour in there, and little by little get this whole area done. Okay, indexing this, we can see that there needs a little bit more of a modification. We're just going to take another 1/2 inch out at the notch. And there we have it. So we'll just continue the process. As I mentioned before, when it comes to saving energy, it's always about temperature difference. In the industry, they call it delta T. What's going on here is, let's just say the hot water heater's set. This one's actually set pretty low because there are only 2 people in the dwelling. But let's just say it's 110 degrees, 115 degrees. Now, this cement block here, on the other hand, in the middle of the winter, because we're way up north here, this cement block might be 10 degrees. So that's a 100-degree swing within, let's say, 6 inches. So that's the real benefit of that big temperature difference for insulating this pipe. Now, this is a relatively new home, 15 years ago. So there's only so much leakage through this box beam area, which we'll be talking about. But imagine if this was a 150-year-old stone house, when this was all a stone wall and there'd be a lot more air leakage. This would even be a more important factor for saving energy because of the cold air leakage coming in. Typically, in most homes, what you have is you're trying to keep upstairs, let's just talk in rough numbers, 70 degrees Fahrenheit. Okay? And because of the heating unit and all the BTUs that it's spreading around, and the earth in the middle of in this floor here, let's just say it's 50. Now, of course, this unit's fighting BTU-wise to keep this area 50, and the block wall might be, of course, as you go lower in the ground, it's going to be a warmer temperature closer to that 50. But typically, from the ground, where the ground ends, which in this particular dwelling would be around here, from here to here is a very cold area in the winter. Plus, we have leakage all around the box sill. Once again, that's the concept of insulating this pipe. Helps this hot water get to its destination before it gets colder because of the proximity of this very cold area. To summarize our hot water pipe insulation project, what we've done here is spent $20 at our locally owned hardware store, used a couple of household tools that you probably have already, taking a couple hours of our time, and what we're doing is saving energy 365 days a year for the lifetime of this home. Come on, America, I know you can do it. This is Passionate Pat with EnergySaverGuy.com.